Hello, my name is Anton Kleshov. I'm a software architect with 15 years of software development experience. Today we're going to be talking about how to create an Agile roadmap for software development project. Before we start, please like and subscribe to not miss any future videos. We have a lot of stuff planned about software development planning, getting ready to be released to this channel very soon. So stay tuned. Alright, let's get into it. First of all, let's set goals and expectations. Suppose that we have a software project and dozens of ideas in the backlog that we want to map somehow into a timeline. We also have multiple teams with different specializations and resources to manage. In this situation, it would be really beneficial to create a product roadmap. Here are a few advantages. First, to provide high-level release date expectations for ourselves and our clients. Second, to define the scope of what we can do. And third, to understand how to allocate our resources or potentially hire someone new. Additionally, let's remember that we have dozens and dozens of features coming in, and we want to be able to adjust the plan at any moment. One example of that would be the famous words of Steve Jobs. He once wanted to remove 70% of the roadmap at some point. So building an adjustable and flexible schedule is crucial for us. Now that we defined what we want, let's break down the process into a few steps. The steps that are essential to build a roadmap are displayed on the screen. Let's go over each step to understand in detail. Step number 1. Identify the roadmap boundaries. How far ahead do you want to plan in the future? Is it the next month, or the next quarter, or maybe some custom dates? It's very important to clearly define this parameter to ensure that you understand what your planned ambitions are, as well as the start and end date for a roadmap. Step number 2. Identify the features, or some call them epics, for a roadmap. In this step, we should look at our backlog and identify good candidates for the planning period we defined in the previous step. It is important that the features are big enough to be trackable on the timeline. If it's too big, especially after completing the evaluation described in the next step, consider splitting it into a few smaller features. Step number 3. Evaluate a high-level estimate for the features and their dependencies. This step is important to understand the weight of the features that we're working with. High-level estimates can be represented by a single record. However, it's much better to present it as a number of records, with each record representing a particular type of job required and specialization, for better accuracy of schedule results. If you want more information on how to perform a high-level estimate for a feature, you can review a dedicated video on that topic. Besides the estimate, you may also want to figure out the dependencies in this step, to have a better logical reference in your roadmap. Step number 4. Define the available resources. The resources we are talking about are teams, their roles, specializations, and velocity. Each team is unique and may have different skill sets and professional levels. Based on that, they can produce a different output. It is essential to record this output in this step. Write down team velocity and their responsibilities in the process. Step number 5. Calculate the timeline to match features to team resources and the roadmap boundaries. This is the key step in the process and the most complicated one. It is important to understand that one can use multiple strategies to execute the features. Let's take a look at some of them. The first strategy is a strategy to minimize cost. The strategy is optimal to achieve maximum value for a bug. The features are stacked in a timeline the way the team velocity is used by maximum, and there is no possible idle time for teams in the schedule. To implement the strategy, one needs to match the teams to features and find the best matching combination to maximize team performance. While the strategy is effective, it's important to put reasonable limits to make sure that teams are not overloaded with works and projects. Some metrics like projects and team efficiency can help with that. I talked about this metrics in the video about resource utilization. Some additional metrics could include burnout indicators, sustainable pace, or buffer times to maintain team health. The second strategy is a strategy to maximize the output of features. This strategy is optimal to deliver the maximum features from the backlog. In this case, the cost may not be the final factor, because each feature by its value may be much higher than the immediate development cost, and the timeline will, first of all, try to accommodate the delivery of as many features as possible. While the strategy can sound attractive for managers and stakeholders, it's still important to balance it with the availability of resources, potentially fine-tuning the algorithm to allow deviations for better resource utilization. The third strategy is to maximize the output of priority features. This could be named a variation of the previous strategy, but with a proper accent on feature priority. Whatever goes first on the backlog should go first on the timeline. This is the main idea of the strategy. While this strategy can seem really attractive to stakeholders, one needs to use the strategy with great care, as it has a really high risk of resource use inefficiency and performance pitfalls. Thus, it must be balanced with proper resource utilization strategies. Let's go over a practical example to define a roadmap to see the picture in a closer look. Let's assume that we need to build a payment gateway solution. Let's go over each step to define a timeline. Step number 1. Identify the roadmap boundaries. Let's say we plan it for the first quarter of 2025, so it will be January 1st, 2025 to March 31st, 2025. Also, just for the record, the amount of business days for these boundaries is 60. Second step is to identify the features. Let's assume that we need to implement the following features for the project: ACH and credit card payments, recurrent payments, and payment settlement. Step number 3. Evaluate a high-level estimate. Let's assume that we have the following estimate for these features provided by the technical team. Step number 4. Define available resources. Let's assume that we have two teams available to perform the work needed for our project. Both teams have dev, QA, and business analysis resources to execute the work, with different calendar day velocities. Calendar day velocity constitutes to a measurement that defines how many man-days the team can contribute per calendar day. For example, if the team has 3 developers, 2 testers, and 1 business analytic, their velocity can be defined as 3, 2, and 1 man-days correspondingly. Step number 5. Calculate the timeline. I get a warning that this step will require some skills in math. In this video, I will show an example using math and manual calculations. If you don't want to do the math, you can watch the video where I explain how to do it automatically by using Deep Planner to simplify all the process to elementary inputs. Alright, let's get into it. Let's use a strategy that minimizes cost and makes teams less idle. The core concept of the strategy is to prioritize the teams most efficient in implementing features. The formula of calculating team efficiency is displayed on the screen. Let's use those calculations in our example. To calculate team efficiency, we need to first calculate the number of calendar days the feature will take for the team to implement. In order to do that, we need to divide the feature effort for each resource by team calendar day velocity for each resource, and then sum them together. For example, in feature 1, you can see calculations on the screen. Then we need to calculate the total team velocity. In order to do that, we need to sum together the team calendar day velocities for all resources. To calculate feature effort, we just need to sum up the effort estimate for all resources of our feature. Finally, to get team efficiency, we need to divide the feature effort by total available team velocity for the calendar days scheduled. With this calculation, we can say that the team 1 efficiency for implementing feature 1 will be 42%. Let's calculate the other efficiencies the similar way. In our case, feature number 2 implemented by team number 2 is a winner, so it will be the first feature that will go on the roadmap. The feature will take 31 man-days, that corresponds to half of the quarter in our timeline. Before we continue with the next feature, we need to adjust the velocity of the team to accommodate the new reality. In our case, we need to subtract the velocity of team number 2 by roughly 50% to accommodate its occupancy with feature number 2. After that update, we can see that it seems too low to even consider using team number 2 to implement any new features in parallel, because the efficiency will be extremely low. So we can just use team number 1 and feature 1 and schedule it in parallel to the already scheduled feature for team number 2. According to calculations we did earlier, it will take around 21 man-days to implement this feature, which will correspond to around 1/3 of our timeline. The updated velocity of team number 1 you can observe on the screen. Finally, we need to decide, what do we do with feature number 3? Should it be scheduled to team number 1 or team number 2? From our initial calculations, we can see that team number 2 would be more efficient than team number 1 to implement that feature, but team number 1 is released earlier than team number 2 for implementing the feature assigned to them. With that, we can make an assumption that the 10% difference in efficiency will be compensated by the 2 work weeks of difference between them. With that in mind, let's schedule feature number 3 to team number 1. Through our calculations, it will take around 15 man-days to implement feature number 3. The final roadmap will look like this. This roadmap corresponds to the most resource-efficient schedule for implementing selected features with the resources available. One last point here. Let's consider an example when somebody comes in and asks to change the schedule because a new feature just came in or there is a drastic change to feature estimates. Try to guess what happens in this case. Exactly. Just go over the same steps. Start with step number 1. Did you already go through half of the roadmap? In that case, adjust the boundaries to reflect it. Completed a feature and added a new one. Adjust the feature list in step number 2 and step number 3. New team member. Time to adjust step number 4. Just add a feature to the list, update all features completion status, and change estimates accordingly. Complete your adjusted schedule with calculating a new timeline. Recalculate all efficiencies and stack all the features according to the new numbers. Don't forget to notify your teams about the changes made. Having an effective and comprehensive algorithm allows for quick changes and flexible schedules that can simplify and advance the whole development process. This was an example of the most simple roadmap creation. If you want a more complicated example with feature dependencies or potentially reviewing an example with a different roadmap build strategy, let me know in the comments to this video. I hope you enjoyed this video. If yes, please share it and press the like button. If you're interested in learning more about the methodologies that inspired this video, please check out this channel and consider subscribing. You can also check the website dplanner.io, where we have various resources about planning and the planning tool you can use. Thank you and have a good day.